Welcome everyone. We are discussing inverse circular function. Today I will discuss how to simplify inverse circular function and then how to find derivative. So for simplification of inverse circular function we need formula of trigonometry, basically formula of multiple and submultiple angle. Now look, problem number 1. Y equals to tan inverse cot x plus cot inverse tan x. This is board's problem of 1. So tan inverse cot x plus cot inverse tan x. So look, you know tan inverse tan x equals to x if x belongs to minus infinity to plus infinity. So our main aim will be to convert cot x in terms of tan. So it is very simple, you know, from your idea of class 10, cot x in terms of tan is tan pi by 2 minus x plus cot inverse tan x, this is cot pi by 2 minus x. So if you simplify, you get pi by 2 minus x. Cot and cos inverse absorb, so pi by 2 minus x. Tan inverse tan x is x, cot inverse cot x is x. So what is the simplification? Pi minus 2x. So this is simplified form. So simplified form of number 1. Now then find derivative. So what is dy dx? So derivative of pi, this is constant 0, so 0 minus 2 into 1, that is minus 2. So derivative is minus 2. So simplify the inverse trigonometric function if possible, then perform derivative. If you use differentiation by direct method, then you have to use tan inverse cot x. Formula of tan inverse x, 1 by 1 plus x square into dx of cot x. It will be lengthy. So our main aim will be for performing derivative of inverse circular function. Our main aim will be simplify it in the simplest form, if possible, then perform derivative. Now second one also, look, this is sec inverse. Here argument is x minus 1, x plus 1. Here argument is x plus 1 by x minus 1. That is reciprocal of it. Reciprocal of it. Now you know sec inverse x equals to cos inverse 1 by x. So look, if we transform it in terms of cos inverse, it will be cos inverse x minus 1 by x plus 1, and this is sin inverse x minus 1 by x plus 1. So cos inverse x plus sin inverse x. What advantage we are getting? Look, they are of same argument, x minus 1, x plus 1. Now you know cos inverse x plus sin inverse x equals to pi by 2. So if you simplify it, so y equals to this is pi by 2. Cos inverse, this is y, this one also y. So what is the simplification? Y equals to pi by 2. So dy by dx equals to square. So first simplify it, then perform derivative. Now problem number 3 and 8, they are of same type. They are of same type. Now you consider problem number 8. So y equals to tan inverse a cos x minus b sin x by b cos x plus a sin x. So our main aim is to simplify this one, then perform derivative. So look, if we use formula of direct derivative, so tan inverse x, derivative of tan inverse x is 1 by 1 plus x square into ddx of argument. This will be lengthy. So our main aim will be to simplify it if possible. So since it is tan inverse, so our main aim will be to convert this argument in terms of tan. So what is formula of tan a plus b? Try to recall. Tan a plus tan b by 1 minus tan a into tan b. So this is our formula. So to make it 1, look, this one is 1. You have to divide by b cos x. So if you divide by b cos x, this is 1. This is a by b tan x. Dividing throughout by b cos x. So this is b cos x. Dividing it by b cos x. So you are getting this one is a by b and minus tan x. A by b minus tan x. So we are getting this. Dividing throughout by b cos x. Now try to use formula. Tan inverse x plus tan inverse y equals to tan inverse x minus tan inverse y. So tan inverse x minus y by 1 plus xy. So this is our formula. This is compact formula. So we can use tan inverse x minus y by 1 plus xy as tan inverse x minus tan inverse y. So it will be formula of tan inverse. X is replaced by a by b and this is tan inverse tan x. Tan inverse a by b minus tan inverse tan x. So this is compact formula. If you write it into expanded form, you get this one. So now this one is tan inverse a by b minus x. So this is simplified form. This is simplified form. Now how to perform derivative? So dy by dx. So tan inverse a by b. So derivative is 0. It is constant, not involving a and b. This is minus 1. So you are getting derivative as minus 1. So it should be noted. In performing derivative of inverse circular function, you must simplify it if possible, then perform derivative. Now third one is also simple. So this is problem number 8. So problem number 3 also very simple. And this one 7. This is also direct formula. You do tan inverse a plus tan inverse x. Problem number 7. So tan inverse a plus x by 1 minus x. You can expand it into two parts, tan inverse a plus tan inverse x. So this is simplified form, then perform derivative. So you complete it. Now, problem number 4. Y equals to tan inverse cos x by 1 plus sin x. So, there is a restriction pi by 2 less than x less than pi by 2. So, this is our restriction. So, first we simplify it. Our main aim will be to express this argument in terms of tan. So, look, you can write it as tan inverse cos x. You can write it as sin pi by 2 minus x. And this sin x as 1 plus cos pi by 2 minus x. So, you may say, why I am expressing it in the form of cos x as sin pi by 2 minus x? Because we know formula of sin x, 2 sin x by 2 cos x by 2. Formula of 1 plus cos x, 2 cos square x by 2. So, this is our main aim. So, this one is tan inverse 2 sin pi by 4 minus x by 2 cos pi by 4 minus x by 2. So, formula of sin x is 2 sin x by 2 cos x by 2 and 1 plus cos x 2 cos square pi by 4 minus x by 2. So, 2 cancel. So, this is tan inverse. So, 1 cos is cancelled, tan pi by 4 minus x by 2. So, this one. So, now if no restriction is given, tan inverse tan x we take as x. But here restriction is given. So, try to recall tan inverse tan x equals to x. X belongs to minus pi by 2 to plus pi by 2. So, this is our restriction. So, here restriction is minus pi by 2 less than x less than pi by 2. So, divide by 2 because argument is x by 2. So, minus pi by 4 less than x by 2 less than pi by 2. Now, this is minus x by 2. So, multiply it by minus. So, pi by 4 greater than x by 2 minus x by 2 greater than minus pi by 4. So, if we multiply in equation by negative side, then in equation reverse is direction. Then this is pi by 4 minus x by 2. Add pi by 4. So, pi by 4 plus pi by 4. So, pi by 4 plus pi by 4 greater than pi by 4 minus x by 2 greater than pi by 4 minus pi by 4. So, finally what we are getting? So, pi by 2 greater than pi by 4 minus x by 2. This is also greater than 0. So, or you can write it. So, or you can write it in this form, in reverse form. So, look, 0 less than pi by 4 minus x by 2 less than pi by 2. That is, this argument belongs to principal value. What is principal value? Minus pi by 2 to pi by 2. If this argument belongs to principal value, then tan inverse tan x is x. So, we are getting this argument in 0 to pi by 2. That is, it is within principal value. So, in this case, so tan and tan inverse is absorbed pi by 4 minus x by 2. So, this is the simplified form. So, what is simplified form? Pi by 4 minus x by 2. Now, what is dy dx? So, 0 and x by 2 is minus. So, first you simplify it, then perform derivative. So this is our limit. Now second one. So you can also solve it by factorization method. Look, cos x. This is cos square x by 2 minus sin square x by 2. Formula of some multiple angle. 1 cos square x by 2 sin square x by 2, 2 sin x by 2 cos x by 2. Now this one equals to tan inverse. So if you factorize it, cos x by 2 minus sin x by 2, cos x by 2 plus sin x by 2, and this is cos x by 2 plus sin x by 2 whole square. So one term is cancelled out, tan inverse cos x by 2 minus sin x by 2, cos x by 2 plus sin x by 2. So now we have already solved this type of problem. So this is tan inverse dividing by cos is 1 minus tan x by 2, 1 plus tan x by 2. Now what is our main aim? To express it in terms of formula of tan. So tan A minus tan B. For 1 you can write tan pi by 4, and this one I am saying tan pi by 4 into tan x by 2. So this is tan inverse tan pi by 4 minus x by 2. So you can also simplify using this method. So we have already, it is already shown that pi by 4 minus x by 2 belongs to principal term. So pi by 4 minus x by 2, this is y. Then you can perform derivative. Now problem number 5, this is exactly same. Now problem number 6, y equals to tan inverse 1 minus cos x by 1 plus cos x into y, and there is a restriction. So what is the restriction? Restriction is minus pi less than x less than pi. Now this one is tan inverse 1 minus cos x, 2 sin square x by 2, 2 cos square x by 2 total. So tan inverse tan square x by 2 total. So tan inverse mod tan x by 2. So if no restriction is given, we suppose it is in first quadrant, then mod tan x by 2 equals to x by 2, and this is x by 2. But here restriction is given minus pi to plus pi. So look, minus pi less than x less than pi. Argument is x by 2, minus pi by 2 less than x by 2 less than pi by 2. So interval is pi by 2 then minus pi by 2. In 0 to pi by 2, tan x by 2 is positive. So we are getting tan inverse tan x by 2 if 0 less than x by 2 less than pi by 2. And in this restriction it is negative. So tan inverse minus tan x by 2. So what is the restriction? So restriction is minus pi by 2 less than x less than 0. So this should be okay. If no restriction is given, we suppose it is in first quadrant. But here restriction is given, so we are dividing it into two parts. So what is y equals to x by 2 if 0 less than x by 2 less than pi by 2 and equals to minus x by 2 minus pi by 2 less than x by 2 less than 0. Then you perform derivative. So if it is board problem, you can write tan inverse tan x by 2 equals to x by 2 because we suppose x is in first order. So what is dy by dx? Dy by dx is equals to half. You are getting same magnitude but opposite in sign. Minus pi by 2 less than x by 2 less than 0. So this is our dy by dx. So simplify the given trigonometric function into simplest form, then perform derivative. So today, through this video, I have solved some simple problems of inverse circular function. That is, problem is to be simplified into simplest form, then perform derivative. So this is most important for any competitive exam. So thank you for today.